up for you. Let me first change the settings. Yes, you guys will draw mountains here. Statistics. You guys know that we are having two branches of statistics, descriptive and inferential. Guys, you don't need to remember anything, okay? Just leave everything, sit back and relax. Inferential, okay? In descriptive, you guys know that we are having measure of central tendency, measure of spread. This thing I have already given you the idea of, so I'm quickly writing it down, okay? Now, for inferential statistics, guys, you guys have seen for the standard normal distribution, we have already done the descriptive stats. Right? How descriptive statistics we have done? We have seen the standard deviation, we have seen mean, we have seen median, we have seen quartiles, everything. Okay? Now for the inferential statistics, we are going to deal with the standard normal distribution. So understand this thing, guys. You are having the Glaxo and BML data set. You treated that data set with standard normal distribution. Okay. You have done the descriptive statistics on the data set. Now you're going to do inferential statistics on the data set. Okay. So this descriptive part for this SND is over. We will talk about the inferential part. Now what all comes under the inferential part? So inferential part contains, let's say, point number 1, confidence interval. Okay. Central limit theorem. Let me write it down. Confidence interval. Central limit theorem. Hypothesis testing. Regression analysis. Okay. So which one we are going to do tomorrow? The confidence interval. Now understand this thing for the descriptive statistics, as I told you, when your data set is bit small in nature, that's when you use descriptive statistics, right? Because my quantity of the data is small and I can give this descriptive approach and I can understand what the data set has to say. Now, since we are having data set very huge in nature, okay, consider you are having 1 lakh or 2 crores of entries. When we say or when we apply inferential statistics, understanding this is very important. Okay, when we are having countable infinite type thing. Do you understand what is countable infinite? Countable infinite means, understand this thing very carefully. Descriptive statistics you are going to perform in countable finite. You can count it and it is finite as well. Whereas inferential statistics, we are going to apply on countable infinite type of data. Which means what? Suppose if I ask you to measure the height of every person between the age gap of 18 to 20. I'm now not telling you what is the exact population. I am telling you, go roam around the world, find the people of age gap between 18 to 20, measure their age, give me that entry. So, if I give you an hour, you are going to capture 40, 50, let's say 100 people, and you are going to give me the data of that. Okay? But if I ask you to do this without time limit, do you know what all entries you are going to gather? Do you know that is there any end of this? Do you know when you are going to finish this particular data entry? No. That is countable infinite. Countable infinite says that we are having a huge variety of population. We are not having the control over the population. But if somebody gives me the span of the time, I can make it countable in nature. Okay? Again, suppose if I give you the bucket of rice. It is filled with rice grains. Okay? Now I'll ask you to count the rice grains. What you will do? If I give you 15 minutes, you can give me the count of some of the rice grains. Okay? is countable. But if you see the nature of the rice grain present in the bucket, it is infinite in nature. So similarly, the nature of population is infinite, but within the certain period of time, if you count it, then it is countable infinite. Am I making sense? What is countable infinite? Getting the idea, guys? Yes, no, maybe, or you already lost interest.
Can you come again?
Yes, getting.
Okay, so let me give you the example once again. When the population is very huge in nature, okay, and you guys don't have the idea that it is countable or not, okay. Suppose if I ask you the question that how many people travel in train, okay, on daily basis, you know, we don't even know how many trains are running because we're normal people, right? We don't work for railways. We are normal people. We don't know how many trains are running. What is the capacity of every train, right? What is the consumer activity? From there, they are boarding. From there, they are arriving. We don't have any idea. It is the huge population. Now, bet if I give you 1 hour, I'll ask you, I'm giving you 1 hour. Please count the number of passengers. For those who are traveling in the train. By default, you will come up with some 100 or 200 entries. So what will happen in that case? Yes, of course, you are having the huge population. But if given you certain times, you can count it. Till somewhere you can count it. Not fully, but somewhere you can count it. It is countable in nature. Not like liquid, which is not countable. I cannot count liquid, right? Similarly, your fluid type of things, okay? The things which are not countable, we don't have count of it. Those are uncountable, right? But the things which we have count, but the population is infinite. That's why we say that inferential statistics we use for countable infinite type of data. Getting it? Always understand that in the inferential approach, when the data set is countable infinite, we always fetch the data countable infinite for some particular time span, and it will give me the small entry of population. Okay, so the countable infinite is your population. Sorry, my God, infinite is your population. Okay, and you are making it countable within certain period of time. Small entry is going to be your O. Now inferential statistic works, guys. I'm telling you once again because we are going to cover this anyway tomorrow. Inferential statistics says that you can apply the descriptive approach to the sample. Descriptive means this approach to the sample. And later you can say that it is same for whole population. Getting it? So what? Again, consider the example of the train. I ask you, I'm giving you 1 hour. Give me all the entries of the passengers who are boarding to the train. What you're going to do? You'll fetch up the entries for me. Okay, that is going to be small sample. Let's say you come up with 1,000 entries. That is going to be the small sample for me. What? The whole population. What is the population? Every passenger who is boarding the train. Okay. So from whole population, we picked out the sample of the data. And now in this sample, we are going to apply the descriptive statistics. And after the descriptive statistics application, once we reach to the conclusion, I'm going to say that it is the similar for the whole population. The statistical overview of the sample is similar to that of the population. How this is going to happen? This is going to happen with the help of confidence interval, central limit theorem, hypothesis testing, and regression. Making sense what it is? What is inferential statistics and why we are going to apply confidence interval? It is going to be the sample of my data set. I'm going to apply confidence interval to find something for the sample. And later I will claim that The thing which I am finding for the sample is going to be same for the population. Okay? Any questions? Okay? Since you are not having any sort of question, then we are done. Okay? I'm not stretching it much. Tomorrow we will be continuing from here only. First, we will understand what is confidence interval. Later, we will do what? That is not the part. This is the part. Just a moment. Population sample coming into the picture. Yeah, what is CI? Understanding confidence interval is very, very important because you guys need to understand that this is something which we will be needing in upcoming hypothesis testing or any other type of testing. Okay. With the term confidence interval means what? I told you yesterday that inferential statistics is the concept where we are going to talk about population and sample. Now, yesterday I also told you one thing, that population is going to be the countable infinite type. Okay. So let's say yesterday I told you that the population is going to be the countable infinite types. Okay. Now I have also given you the example what we call countable infinite, something which we can count within the period of time, but actually it is going to be infinitely countable in nature. Okay, the value is so large that we don't know how much time it is going to take for us to cover the counting, overall counting. Now, what is confidence interval? Understand one thing, that in inferential statistics, I told you, first we have to follow the descriptive approach. Okay, in the sample, we are going to apply descriptive approach. And whatever descriptive approach we are going to find for the sample, we are going to say that is same for the population. Okay. Now understand that here all the things revolves around a term called as probability. Okay. Probability means what? If I am claiming that suppose if I find the mean of the sample. Okay. Here now I'm finding the mean of the sample. Suppose if I'm finding the mean of the sample, I'm going to claim that if the mean of the sample is similar to that of the mean of population. In that case, what will happen? You will ask me, what are the chances that what you are saying is correct? Right? And now if you understand that we are dealing with a continuous type of data, okay? When we are talking about continuous type of a data, you know that the values are going to be very unique and it is going to be very variable in nature. Okay? Means what? Every next entry, you might be finding something different from the previous entry. And even if you try to judge the output, you won't be able to. That's why we have, dealing with the continuous type of data, we have some thing called as probability density function. Yesterday, you guys already seen that. Now, coming back to the confidence interval point, when we are claiming that any statistical parameter we are finding for the sample is going to be same for the population, somebody will ask you, what is the confidence? What is the probability that what you are finding is correct, right? So understand this with example. If you guys can see, it is the blurred outline written in the right in front of your screen. We want to know the height of all professional basketball players in USA. Now, from this particular statement, you need to understand that we have to give inferential approach. We cannot give descriptive approach. Why? Because professional basketball players in USA is countable infinite type of data. If I give you an hour, of course you can come up with some data set. But suppose if I ask you to bring me all that data set, I don't know how many hours or how much of time you are going to take. That's why we are calling this as countable infinite. Now, for this situation, what we will do, we are going to draw the sample. Usually in such cases, what we say that population is unknown. Basic सी बात है. If population is unknown, then only we are going to extract the sample, find something for the sample, and then we'll say it is the same for the population as well, right? This is how it is going to be. Understand that any statistical parameter, yeah, I'm repeating it. Any statistical parameter you can find for sample and you can claim that it is same for the population with the help of confidence interval. Now, what are the statistical parameters, guys? Could you name some of them? In the chat box, don't unmute, please. If I'm saying statistical parameters, what do you guys understand from that? And now, what is the brief of the confidence interval? That you are going to find such things, that will help you to, let's say, calculate the statistical parameter of the sample. And then you can say that it is same for that of the population with some confidence. Okay. Don't worry, box plot and histogram will cover that while performing exploratory data analysis. Okay. That is going to be the separate concept. Don't worry. Coming back to this point, now since we are talking about this sample thing, I told you it is not about mean. Okay. You can find standard deviation for the sample. You can find variance for the sample. You can find mode. You can find median, whatever you want to. And you can say that it is same for the population as well. Now, I'm repeating this statement again and again because whatever falls under the category of inferential statistics is going to work similarly only. Connect the dots, guys. Okay. Now, suppose you are having the population which is unknown. Okay. Every time your population in the inferential case is going to be unknown. You have drawn the sample. In the sample, you have applied descriptive statistics. You are claiming that whatever the sample answer is, it is going to be same for the population answer. Okay, no problem. Understand that with what % confidence. So it is telling you that what is the likelihood, whatever you are calculating for the sample is same for the population. Because guys, we are not having knowledge of the population data. We cannot make the claims, right? I am just simply picking the sample, doing some descriptive analysis, and I'm saying that it is same for the population. And understand this one thing, we cannot be accurate. Of course, we can be near to the correct answer, but we can never be accurate. Right? Makes sense? Because you know that your population is unknown in nature. How I'm going to make the exact value for the population, which is same for the sample? Not exact, but near to exact we can find. Okay, but the question is now how? You will see, you want to know the height of all the professional basketball players in USA. You can say this is your size. Let's say this is your population. So for this population, you extracted this sample. Okay, now understand this sample is completely random. Okay, this is something which we need to make a note about. This sample is completely random in nature, which means randomly I'm going to pick up the sample out of the population. Okay, that's why we call this as a random variable. Okay, why random variable? Because the elements present inside the sample means it is completely random and I don't have any sort of idea. And this is how it is going to be, which means you never should use your brain while drawing the sample. Why? Because you always end up being biased. Because you are human. Suppose you like some of the entries or methods. You pick up those entries. Now, accidentally, it is becoming biased in nature. This is what happens every time. Okay. So in this case, you need to remember when you are having population and when you are having sample, the sample is always going to be the random one. Suppose we have drawn one sample. Okay. Now, consider this is the mean of the population. Okay. And we know with some calculation, let's say census calculation and university calculation, we have a just idea, assuming. Okay. Since we are having this as the center of the mean, or let's say population. We are having the mean of the population. I have drawn the samples from the population, and you can see it is not exact. There is some sort of variation between them. So the mean of sample is most likely different from that of the population. So most likely it is same, which means we are near about each other. Okay. Now understand that we are talking about sample number 1. Sooner or later, we'll hop into the sample number 2. Okay. Now you can see each sampling is likely to come out with a different mean. Understand that. Now this is again, which is something we need to talk about. We have drawn one sample, we have calculated the mean. Okay. Now we have drawn another sample, which is again random in nature. We calculated the mean for that sample. Now again, I have drawn some sample, we calculated the mean for that sample. Okay. Now since this is done, you need to understand one thing, that every sample mean is coming different from one another. In such cases, it will get difficult for us to make the claim, right? Which mean is equivalent to the population mean? We don't know, because we are drawing the random samples. There is a possibility that Shivam is going to draw this sample. I am going to draw this sample, or let's say Lavanya is going to draw this sample. And according to our samples, every mean is different. Then how I can say that it is equivalent to the population mean? Here in this case, your confidence interval comes into the picture. You can see. Just. Okay. Now, since we have drawn different mean for different samples, it is very useful to know the range. Now, basically, what is going to happen? Suppose I have drawn 3-4 samples altogether. Okay. After drawing 3-4 samples altogether, this is my ending sample and this is my starting sample. Just a minute, guys. Okay. So this is the, let's say, the ending value or the mean which you guys have found. Okay. Now this is the starting value of the mean which you have found. Okay. Now this is the third value which is coming in between. Okay. So suppose I have drawn 3 samples and now this is completely your choice. We usually go till 3 to 4 samples. Then we try to find the mean of those samples and we see if the mean is coming near to one another, which is very basic part, right? If consider, this is a very, very basic thing, that if you're having the population mean somewhat like this, and you're drawing the samples out of the population, you will see the pattern that every mean is coming close to each other. Okay, close, not accurate, because as I told you, it is continuous type of a data, and every data is very unique in its nature. So we are never going to get the precise exact value. You will always find likelihood, near about. Okay. So now if we have drawn 3 samples, and from that, those 3 samples, I want to identify which is the mean for the population. In that case, we will get stuck. So for that situation, we identify the range. What do you guys think? What is the range? Whatever the maximum mean you found minus minimum mean you found. Whatever the between value is going to come, we call that as a range. And if you read the line written here, in which the true value will lie with a high probability. Understand that? Let me give you one example. Okay, let's pick up that similar example of basketball players. Now, suppose you are having different universities, the diversity is very high, and you are having different type of basketball players in your university, right? Now, somebody asked you to calculate the mean average height of the basketball players, so that point number 1, every player should get the equal chance. It's not going to be like somebody is extremely heighted. So that person is going in advantage over the other teams. And someone who is very small in height, it will go with some other advantage or disadvantage in the team. Okay. What are these points are going to be called as, guys? Someone with extremely higher height and someone with extremely lower height. In the data set or in the population, what do we call them as? outliers, right? Guys, please change your chat settings, not direct messages, okay? It should be to everyone since we are having discussion. So we call such type of values as outliers, okay? So to avoid such situations, my university people and the facility, they thought that we will find the mean of whole population. Since we are not sure that how many people are going to play, they asked us to draw the samples. Now, I have drawn sample from University A, then I have drawn samples from University B, drawn samples from University C. The best part about mean is that when you are talking about data set, mean always tells you this value for whole column. Okay, suppose if you want to describe the column with some certain value, that is nothing going to be but mean. Okay, so if I ask you to describe the column X, which is salary, so you can say that the average salary of employee is this and this. If I ask you to explain me the column profit, you can say that the average profit is this and this. Okay, this is how we explain. So they end up finding the average of every sample. Now, once I found out that the sample of University A is something else, B something else, C something else, but they are near up to each other. Now I have to answer my people that what is the population mean? How I'm going to do that? I am going to take the help of CI, confidence interval. Confidence interval says that this is the range where we are having the highest chances, let's say 95%, 99% confidence that within this desired range, the value of mean of population is going to lie. Okay, 99% confidence we say. We are about, why 99% confidence, guys? Because there is a possibility that suppose this is a mean is 4.2 here, okay? But the actual mean coming is 4.3. So it is not एकदम precise, right? We never work with precision or 100% things here. Whenever you are talking or doing prediction, understand one thing, it is always going to be with some percentage, not 100%, not for full sure. Because we are here taking the inferential statistics, which only works with claims and probability. Okay, so what I'm saying that I have drawn multiple samples from different university. Now I'm finding the mean of them. Now I'm selecting what is the range for that. And within that range, I am going to say that if we are having the highest probability or highest chances that my mean of the population is going to lie there within this range. Now, let me tell you one more thing. Since we're talking about 3 samples, okay, you can pick 7 samples, then also you will find the range near about to this one. This is the best one. So either you could choose 3 samples or you could choose 7 samples, 10 samples, whatever number of samples you want to choose, you can. But let me tell you, after choosing 3 samples, if you hop into the 4th or 5th one, still you are going to have the range. It is just going to be point difference, but the range is going to be similar. Okay, so that is what confidence interval does or says. That whenever you are having the data set, you want to find, data set means what? Countable infinite type of data set. Okay, you want to perform inferential statistics on this, and you can't find, because it is countable infinite, you cannot find the statistical parameters for it. So you take in the help of confidence interval, you find the mean of the population or any statistical parameter of the population with some highest probability. Okay. Now, the highest probability which we are talking about, it is going to be something like this. Okay. Whenever we talk about highest probability, you can see this range is called the confidence interval. Now, what is the high probability? Now, this is something to understand, okay? When I say high probability means what? For the calculation of confidence interval, guys, let me tell you, you don't need to calculate this manually. Point number 1, okay? We are having the StatPy. We are having if you guys know what is StatPy. StatPy is a statistical Python. Okay. So everything related to the statistics is present there in the StatPy. And I am just telling you, nobody calculate this manually. Everybody, either they take the help of StatPy, or there are so many websites available in the Google that will directly calculate the CR for you. Okay. So for the calculation of confidence interval, the probability percentage with which a parameter should lie in the interval must be defined. Let me tell you that. Understand this thing, okay? It is very important since you are having, this is the first step, okay? You are going to encounter these points, let's say confidence interval, percentage probability very frequently. So understand this thing very good way. Point number 1, confidence interval always works with the normal distributed data set or standard normal distributed data set. Point number 1, if your data set or let's say your sample is equally distributed, then you are going to find the CI unless you cannot. Okay, point number 1. If you are drawing the sample, make the sample come in the normal distribution format and then find the CI for that sample. Okay, point number 2. When you are finding the statistical parameter of the data set, you need to understand that you are going to make a claim. Okay, claim means what? See, we have done the calculation and we think it is going to lie within that range, but with what percentage, right? What is the guarantee that it is going to lie? So that the guarantee is nothing but the probability value. And that probability value usually is 95% or 99%. Okay, we don't choose any other thing. Either we choose 95% or we choose 99%. Now you will ask me why we use this, because it is standard. Okay, when we don't want to go exact precision, with exact precision, we choose 95%. When we want to go with exact precision, we choose 99%. But this we consider to be the safest one because we know that we are human, bound to commit mistakes, and we cannot go this precise and I'm finding with 99% confidence. So the confidence level of 95% or 99% is very often used as the probability. So understand one thing, that whenever you are going to solve the question of CI or confidence interval, this probability level or confidence level is going to be there always. Okay. So they will ask to make a claim what is going to be the average height for whole population with 95% confidence. You can read the question. While reading the question, you will don't even understand what they're trying to say. I have to find the mean of the population with 95% confidence. How I am going to find with 95% confidence? They are talking about this thing, confidence interval. Making sense? Do we have any question? Yes, guys, if you have, you can let me know right now. Statistical parameter. So sorry, I've just written the abbreviation. Statistical parameter. And guys, you can find any statistical parameter. Okay, right now we are talking about mean. Suppose if somebody asks you to find the variance of the data set, population, let's say. So you can pick up the different samples. You can identify the variance and then run. Okay, getting it? What is statistical parameter? You can find the variance for whole population as well. No difference. Yes, any more questions, guys? Anything which you guys are unable to understand? Because this is very basic, okay? Let me tell you, this is the trailer. The picture is yet to come. So tell me if you are good until here.
Yes, we are good.
Okay. Chalo, let me erase the drawing. Let's move on to the next part. Now I'm telling you that you don't need to find anything manually, but the basic sense, guys. If we know the formula, that will be great for us. Okay. So I'm just showing you that how it actually looks like. Okay. Now here we are going to consider the value of z as constant. Okay. In next lecture, or let's say in upcoming Saturday, I will definitely tell you what is the z value. This is something falls under the hypothesis testing. We call that as z score. Okay. So as of now, just understand one thing. When the value of confidence, or let's say confidence level is 95%, then the value of z is 1.96. And value of confidence, let's say confidence level is 99%, then the value z value is somewhere 1.46 something. Okay. You can search it on Google because it is a constant value. Nothing to remember. Okay. We use this constant to find the confidence interval. So the Z value of respective confidence interval can be read from the table. You can see that. Maybe you guys are having the idea or not. Those who are having the stats background, maybe the basic statistical they learn in their school time, they will always give you two things: the stats table and the log table whenever you go for the exam. And you are allowed to read constants from there. Okay. In the exam, you can pick up that book. If you don't know the constant value, you can check in the book, pick up the value and use it. Okay. So that's what the constant value is. You cannot remember every constant value, right? That's why I'm telling you, whenever you will not find the value of C, you can see it is showing you directly right in front of your eyes that you can read from the table. Where you're going to find the table? In the Google. Or you can simply write the 95% confidence interval Z value. Okay. You can do either of the things. Chalo. The next part. Since the 95% thing and the Z value we understand, as I told you, we choose 95% as the standard or the basic. Okay. There's a result in the equation. You can see Ci is equals to x to the bar plus minus 1.96 s divided by root over n. Okay. Now what is this? What is x bar? What is s? What is root over n? Okay. Let's see. No, this is not the same thing. No, let me tell you directly from my end. What is x bar? You will always find the values like this. Okay, x bar, mu, small s, root over n. So understand this thing. Not every time I'm going to tell you the same thing, but yeah, I will tell you what this sign is described. Okay, just. एक सेकंड में but okay. So whenever you will see this x bar, understand that it is nothing but the sample mean. Okay, this smallest is going to say that sample standard deviation. This is the formula, okay? The root over n, or let's say the n says that the number of sample. Or let's say, sorry, what are the number of entries present inside the sample? Okay, the number of entries in sample. So, simple. As I told you, you don't need to find this manually. Okay, everything is going to be there in your, let's say, SkyPy. You just need to understand what all these things are saying. Okay. Chalo. So, do you guys understand? If I'm going to find some statistical parameter, what we are going to find right now, guys? Suppose if I ask you to find the average height of basketball player with 95% of confidence, are we going to find a single value or are we going to find a range? What do you guys think? Is it going to be a single value or a range? It is going to be a range. Okay. And then we are going to say that. Okay. So, yeah. Understand this thing? When we are talking about range, we are going to make the claim that my statistical parameter is going to fall within that range. Okay, that's what we are going to do. Chalo. So these are the basic description of your formula. Okay, understand that this is 1.96. Usually we write Z here or Z here. Now guys, can you see one thing? It is showing plus minus, right? Now from here, your real concept comes into the picture. The concept of critical range, acceptance range or acceptance area. Okay, very important concept related to the inferential statistics. Why this plus and minus coming into the picture? Understand that when we are talking about the graph, there is some sort of tailing in the graph. Okay, as of now, I'm just giving you the overview. Okay, this is not something which is as of now our concern, but let's say maybe after 1 or 2 lecture, it is going to be our concern. As of now, just introduction. Okay, tailings of the graph means what? Suppose we are having a bell-shaped curve. That's what I told you. The first characteristics for applying confidence interval that your data should be normally distributed or standard normally distributed. Since you are having the curve like this, you are having 95% confidence, which means you need to understand the tailing of your graph. The tailing of your graph says that two-tailed. Two-tailed means you guys know which one is the tail of the graph. This is tail number 1. This is the tail number 2. Okay. Now CI is saying that plus minus, it will always going to find some range in the plus direction. Always going to find some range in the minus direction. Okay. And here it will say that this is my range. And within this range, my most of the data point, or let's say my statistical parameter for the population is going to lie. Okay, so this x bar minus 1.96 as root over n is 1 for the negative end. X bar plus 1.96 as root over n is for the positive side. Okay, this is going to be the one range entry, minimum and maximum. What I told you, what is the formula of range? Maximum minus minimum is going to give you the range. And that will give you the entry between these 2 points. And we will say that it is nothing but the confidence interval area. And the another term is going to be acceptance area. Okay, guys, which is very important. We also say this as acceptance area. Okay. What is the rejection area? What is critical point? All of these we are going to cover in upcoming. As of now, understand now. This formula plus minus is going to come somewhat like this in the bell-shaped curve. And this will make us fall under the acceptance area. Here, whatever value is going to become for the population, we are going to accept it. Okay. Getting the point, guys. Any questions still here? No. Anyone? Chalo. If you guys are not having any sort of question, I have a question for you. Define confidence interval in a single line. According to your knowledge. Now, since we have covered a lot about confidence interval and the topic is also over, okay? You have to define confidence interval in a single line. How you're going to define it?